So I'm working on the -9 volt power supply for our 1702 ROM board, and the schematic for the getting ROMs on the solid state music IO2 card basically takes a 7908, which is a -8 volt regulator, and pushes the ground reference up by a volt to get -9 out. And that's kind of what we have. Well, it is what we have here. I've had to tweak a couple of resistor values. I'm feeding in -15. That's actually what my switching power supply produces for this rail here on the S100 bus. And the first thing I don't like is this 8 volt regulator is outputting 8.1 volts, which is disappointing. It's not under load at the moment. Not happy with that because it's made the circuit a little bit harder to tweak. Let's see, that's going back to ground. I can load this with 100 ohms here, and it stays, of course, at the 8.1. That should be loaded back. That's back to ground. Yeah, the breadboard here is kind of a kludge. So I'm going to try a few other of the regulators. I just bought these regulators about a week ago. They came a couple days ago. And see if they're all off by 1/10 of a volt. It would just be easier here if we had one that was closer to actually 8 volts. Okay, that's much better. So I'm already happier with that. Probably being stupid pulling that out with the power on. That one's 8.1. 8.1. Looks like almost all these are 8.1. There's another one down much closer to 8. That one's a little higher than the other two. For most things you wouldn't care, but I do want to get and it's actually measuring negative voltage here. I'm just not saying negative. And there is -8.1. So we had two candidates here. -8.06. .08. So we're going to use this guy. Let me get him back in. Turn the power supply back on. And he's regulating with some load, which is warming up. It's a 100 ohm load. It's drawn all of 20 milliamps. That's not right. Oh, I haven't got the load attached. It's now drawn about 90 milliamps. It was hard to figure out on the -9 volt rail what the current draw on the 1702s was. I think per device it can hit 50 milliamps. We should really only have one device enabled at a time. If it was 50 milliamps and all 8 devices were active, that'd be 400 milliamps. That's getting up there. It's a 1 amp regulator. So I think it was -9 volts, 5%, which surprised me. Again, the data sheets are really old, and so I want to get this pretty damn close to -9 volts. So let me set these voltage regulators aside, get them out of the way. And what I'm going to do now is I'm going to switch in these two resistors that push the ground pin down -1 volt, and that -1 volt gets added to the output. And it should become around -9 volts. This lead here is the ground for the device. I'm going to push that down out of the middle of the resistor divider there. And obviously I did something wrong. Yes, I did. Center pin is the input. I disconnected the input. This is a really old prototyping station I built ages ago. It's unpowered. It's just got a bunch of banana plug jacks on it. Pin 1 is ground. That's the pin I need to push up or push down by the about -1 volt. Let's see how close to -9 that gets us. I am not looking at the output now. Let me think about this. Pin 2 is the output. No, we are looking at the output. Why didn't that offset that? I've got quite a mess here. Am I in the... No, I'm in the right place. No, I'm not. I need to be over here. This is really stiff, getting these leads in. So this resistor, the two resistors to the right are the divider network here, and that 100 ohm sitting there is just for load. And that gets me really close to -9. It was over 9.1 before. So that's a lot better there. Let's put some load on it now. So the current draw now is about 20 milliamps. And this jumps it up to 100 milliamps. And the 100 ohm resistor here will start to heat. And it is. I didn't have a half or a quarter watt resistor. Well, maybe that is a quarter watt sitting there. Yeah, that's a quarter watt. So I've got something larger than a half watt sitting in here, I believe. But there's an electrolytic and disc cap on both sides just to be closer to what the power supply will actually be. I don't know how old these regulators are. I didn't want it to oscillate. Some of the really old 3-pin regulators will oscillate if there's not capacitance around them. Unloaded. It's not jumping around with load or no load. So I think maybe we have the regulator we want to use. We have the two resistors for the divider network we want to use here. I know the 100 ohms getting warm. Oh, it's gotten like hot. Too hot to touch. The real question becomes, is this little guy getting warm? And he's not, which kind of surprises me. It's the current path is really down through him. I've got a 47 ohm in here rather than 56. I guess I could put a 56 back in and see what it looks like. Dogs are excited about something. Who knows what they're barking at. Let me turn off the power supply over here. We'll swap that back to our 56, which is what was in the original schematic. Well, they're really excited about something. And that should actually push the voltage up a bit. Yeah, up to 9.2. That's what I expected. It's already 47 ohm here, just based on the resistors I have. Looks like it's a good working value. So the real question becomes getting this circuit on the card. And I think we're going to tackle that next in this video. This is going to be interesting to do. Trying to decide which one of these positions will be easier to deal with. I think I can mount those two power resistors, or the two resistors over here on the board itself, although what little bit of heat they give off will be over there. It'll be point-to-point wiring on the back. Why are you so barky? Well, when I come back, we'll figure out how to wire this all up on the PCB. So looking at what foil I do have left on the back of the PCB, I think the best location is going to be down here. I've got a power rail that comes up that can be jumpered over to the where the -15 comes in off the bus. That'll give me a spot for a bulk capacitor. I've got a spot here that'll become the output, at least gives me a plated through hole, which could potentially just have a wrap pin and just use wrap wire to bring the power up. I'm undecided. And then I'll have to come up with where I'm going to mount the resistors to push the ground down, but I think that's going to be a pretty good start. So let me figure out where to bend the leads on the regulator here. Flatten them all out. And we'll start by bending over the leads. Need to skew that off crooked. Now I need to insulate the metal tab on the back of the device because it's an additional input from the big ground plane behind. And we're going to use a mica washer for that. We've got a mica washer here. We've got a shoulder washer to isolate the nut. And let me get the other hardware out of this bag we're going to need. Well, that's not going to work. Where'd the scissors end up? Well, just dump the guts out of this bag as well. So I am going to use a heat sink on it. So the stack is really going to be then the mica washer. Screw on up through. Maybe. Having no luck getting all that to line up. Okay, fine. Where'd the screw go? I just sort of drop. Just gonna for now tape the screw into, maybe tape the screw into place. Heatsink, mica insulator, voltage regulator. If I can get the pins to go down through. It will need the shoulder washer as the hole in the regulator. Too small for that screw. No, it did fit down in there. It's just a matter of getting it all lined up. All these little fiddly parts are giving me fits today. Can I get the little nut to start and not lose it? No, I really can't. Ah, wow. Why is that little nut being so difficult to start on there? keeps feeling like it starts, but it's actually not started. It's getting a little bit old. There it goes. Get this all spun back around the orientation I want. These leads are all going to get bent down. Give me some length through the back side of the board. Want to somewhat hold this all in place. Put a bit of tension on the screw. Maybe. Maybe. Mica washer's not centered. Oh, you are kidding me. That little lock washer did a really good job there locking the nut. I want to scooch the mica washer up under kind of square. I don't expect this to produce a lot of heat. It honestly probably doesn't need the heat sink. Before I go any further, break out the ohm meter. Make sure that center tab isn't shorted. It should go to the nut. While I'm touching the washer, getting on the metal tab. It's not shorted through any place, so that's a good sign. I'll kind of pull these leads through if I can get any extra length on them. Let's see, the input is the center pin. Can I get that to bend over? Yes. The output, I want to bend over towards a bit of foil there. My better glasses are downstairs. Wow, these little needle nose are just not being my friend today. So that will take solder there. Output is going to go to that solder hole there. I'm going to go ahead and put some solder on that. The lead's just bent over onto the foil. I need to bridge the center pin. That lead is really corroded. I don't have any light sandpaper here to knock that corrosion off. But a piece of this lead would work well for that. Trying to knock some of the corrosion off the lead as it's been sitting in the air oxidized forever. That piece of lead will work. I doubt I'm going to get it down in the hole with the pin to the voltage regulator, though it'd be nice to get that to push down in there. It's not going to push down in. No surprise. Bend it a little less than 90 degrees. And let's see if I can get lucky. That is the input, and that makes sense to go to there. Get enough solder to flow on there, and of course it moved. Oh, now I moved it. Let's get it onto the foil down here. And then we will reheat this to take the mechanical stress off from me moving it. I've got a second capacitor here, and it needs the negative lead in this case to go to negative power rail, and the positive lead will go to chassis ground or system ground, which is the hole over here. So we'll start by bending this lead. Actually, I could have used the wire off of here. It's going to run from there up there. I've got negative going to the minus, it'll be the minus 15 volt input. Attack that from the front. We'll solder up on the back. We've got a pin there that's really meant for a capacitor, and I could do that as well. Poke the capacitor through, little despiking cap. That gets us some bulk capacitance on the input. Now we just really need to deal with the resistors. Figure out how I'm going to do this. Two resistors get connected to the ground pin, device ground pin, which is the last pin floating here, and to the output. Certainly go on the board over there. Start by getting some lead spacings that work. resistor can go like so. The other resistor potentially like so. No, that's a little too tight. They can sit over here on this edge of the board, right by the regulator. Oops, it would help if I hit the same basic places for the leads to come through. The other one there. Work, I do believe. Not super happy with it, but it'll be good enough. Now let's see, the 47 ohm actually goes to ground. I can pick up ground right there. So let's just do that. Let's just take it directly over onto the ground. That takes the 47 ohm that I've got in here to ground. This guy's actually going to hook to the -9 output, which is there. I'll have to jumper that over. And the center pins will come over to here, so I'll need some jumper wire. Decide what wire to use here. Doesn't need to be super heavy. That's going to be too heavy. That's going to be a little too thin. One thing I don't still have is a good selection of wire. Copper in that wire just looks so shitty. Excuse my swearing. It's an old line cord with really thin, actually copperized aluminum. It doesn't hold a shape, it bounces back. I'm not going to try to solder that. There's some other wire. This is really heavy. But it should take solder very well. So this could come out of right there. Tin that up. Solder the center point of the two resistors together right there. We're going to tack this into it. I'm actually going to wrap that thicker resistor lead up around it and add more solder, and that'll give me a little more mechanical strength there. And that comes to the ground pin, which is the one floating over here. Cut it longer than I need it. That way I can strip extra. Maybe. If I can get it to strip. Wow, I want that strip. I want to strip quite a bit more than that. I think I will bend the ground pin on the device, make sure that's the ground pin back up. I'm not going to be able to wrap that around there, there's not enough room. It would have been nice to be able to do that. Sorry, digging for bits of other wire here. Again, I don't think I can get a lead in there side by side. Oh, I can. Interesting. So I think what I'm going to do is make a little hook. Bend that lead over this direction. Again, I'm just trying to add a little bit of mechanical strength here. See if I can get that to feed through on this side. Let's tin up that wire. Maybe. It's still very hot. And the little hook got bent out of it. great. How did that not grab that? Oh, amazing. I can spin it to every angle on Earth except the angle I need. Let's tension that up. So I've got a little piece of component lead through this hole with the lead to the regulator. There's a hook bend on the end to kind of pull that all tight, and now I'm going to solder that as a unit. And I've bent that bit of component lead over on the other side just to put some mechanical tension on it. Let's see if we can get all this to take solder. It's not beautiful, but we're also going to solder from this side. And that gives me a little better mechanical connection. And I need this lead to come over to the power out. I got plenty of length on the component lead, I just need to insulate it. Could use some small shrink tubing probably to do this. Also got some wire insulation here. It would need to be about that long. Just using the insulation off the wire as a sleeve. Bending it that direction. Sleeve's a little bit too long. And I should probably tack the other side of that resistor. It's going to come to there. I want to bend down. And then back out square, and that way it'll stand off the board a little bit, just a tiny amount. And it will solder on right there. I think that'll work. It's not beautiful. Any stretch of the imagination. And that's got to deliver the -9, assuming that works. So let's see what the ohm meter says here. Figure out what I've wired up here. .56 ohm resistor should go to ground. That is that connection. The center of the tube resistor should go to pin 1, which it does. Pin 2 is the input, and it should come to the negative side of this capacitor. Pin 3 is the output. It should connect to there. Well, looks like it's wired correctly. Center point of the two resistors goes to pin 1, which is ground. The resistor goes to pin 2. Wait a minute. Yeah, the output comes to that. Yep, that looks to me like it's wired correctly. I don't have any smallish capacitors on it. I'll have to figure out where to put them. Looks like I could potentially put one. And really, the next step for this is to, I don't remember which bus pin is the minus 15, whether it's 52 or 2. I've still got to wire that up. That is a bit of progress. We're getting close here. Brother Reclude's doing this. I guess you've probably seen the schematic. I tried using a couple of diodes, using the diode drops to push that ground pin down a volt, and I just couldn't find any diodes that, all my diodes forward voltage was 0.6-ish. I couldn't find two at 0.5, which is why I went back to the resistors. So, but that was something I attempted off camera. That is a bit of progress. I need to figure out, like I say, which pin is going to be power input off the bus. There should be no connection through there, and there's not. I do have a big ground area up here that could have some despiking caps attached. Not that I expect a huge amount of current draw on that. Well, I'm just part way through the -9. I will give this some thought. I think this video's rambled on long enough. We'll talk soon.